So, simplifying and eventually multiplying and dividing rational expressions. So first of all, we need to make sure that we know what we're talking about when I refer to a rational expression. The technical definition of a rational expression is that it is the ratio, that's where the rational comes from, it is the ratio of two polynomial expressions. So I have three different examples there of what can be considered a rational expression. Okay, typically we think of things that are a little bit more complex, but it can also be very simple. Negative 5 over x is a rational expression. 7 over x minus 1 is a rational expression. Okay, all of those pretty much, if there is an x in the denominator, it's a rational expression. There doesn't have to be an x in the numerator. Okay, the first example there, negative 5 over x, there's not an x in the numerator, but that's still a rational expression because there's an x in the denominator. Okay? So, we're getting ready to simplify these things, so I always want to try and relate this back to real numbers so that it makes more sense. So, 18 over 4, if we're trying to simplify 18 over 4, okay, it's simplified not by typing that into your calculator and pressing math enter, right? To truly simplify that, you're looking for what do they have in common, and you're going to cancel that out. So we could rewrite 18 over 4, we could rewrite 18 as 2 times 9, and we can write 4 as 2 times 2, and those 2's that are in the top and in the bottom can cancel. That's why 18 over 4 is equivalent to 9 over 2, because you can cancel out a factor of 2 from both the top and the bottom. So we're going to do that with polynomials. Okay, we're going to do that with polynomials. So let's look at this. These are not from the worksheet that I just gave you. These are separate examples. Okay, so you can write them in your notes there. Let's simplify this as much as we possibly can. So to simplify 18 over 4, we factored 18 and 4, essentially. So we're going to factor these polynomials. Any type of factoring is fair game. GCF, regular, just basic trinomials, difference perfect squares, perfect cubes, grouping, it's all fair game. So that numerator, what I see first is a GCF of x squared minus 4. That's what we're left with. And in the denominator, x squared plus x minus 2, going to go ahead and factor that. That's x plus 2 times x minus 1. Not finished factoring in the numerator. X squared minus 4 is the difference of perfect squares. So I can take that a step further. X times x plus 2 times x minus 2. And then there's nothing else I can do to the denominator. So I leave it. So now it's, what do I have in both the numerator and in the denominator? Well, we've got x plus 2, and that's it. That's as far as we can go. We've got x times x minus 2 over x minus 1. You cannot cancel those x's. The x that's in front and the x that's in the denominator, you can't cancel them because that x in the denominator is attached to the minus 1. Please don't cancel those. Yes, you can leave the parentheses. If that removes the temptation, you can leave the parentheses there. That's fine. Just be aware that they won't show up on an answer key, okay? All right, let's look at another one. We've got 12 plus x minus x squared over 2x squared minus 9x plus 4. 12 plus x minus x squared over 2x squared minus 9x plus 4. The first thing that I don't like about this problem is that the numerator is not in standard form. So just to save myself some space, instead of rewriting the entire thing, I'm just going to rewrite this kind of over the problem, and then I'll start factoring, okay? So I just changed the order. I put it in standard form so that it's in the order that I'm used to when it comes to factoring. First things first, bless you. We don't like negative leading coefficients, so we're going to factor out a negative from that numerator. So it changes all of our signs in the numerator only. And I'm going to have to write another line anyway, so I'm just not going to factor the denominator yet. Okay, so once we get rid of that negative, we get x minus 4 times x plus 3. And in the denominator, 2x times x gives us 2x squared. 2 times 4 will give us 8, and those are both negatives. 2 times 4 is 8, 8 and 1 makes 9. Again, I've been factoring forever. That's why it comes so quickly and easily to me. Do not be freaked out by that if it takes you a little bit longer. Okay. X minus 4 in the top and the bottom, so we cancel those. So you can leave it like this, or be aware that on the answer key, you could see it with that negative distributed. Okay, you could see the negative distributed. And sometimes, I know this is kind of weird, but we've got 4 terms here between the numerator and the denominator, right? We got 2 in the numerator, 2 in the denominator. When the majority of the terms, in this case 3 of them, are negative, what they'll do is they will actually factor out a negative from the top and the bottom, and so you can cancel the negative. So this is actually, I know it doesn't look like it, but this is the same thing. Just changed all the signs. Okay, you factor out a negative from the, let me show you that instead of just saying it, let me show you. Okay, the negative out of the top, take a negative out of the bottom. Okay, so a negative over a negative is a positive, or they cancel, either way you want to look at it. Okay, and then sometimes they just don't like that negative in front, so they change the order. Okay, so it's 1 minus 2x. Same thing. I just wanted to show you that, because sometimes they do that. When the majority of the signs are negative, they'll factor out the negative so that they don't have so many minus signs. So when you're trying to compare your answer to an answer on the answer key, as long as all of your signs are the opposite, those are the same answer. As long as all of your signs are opposite, it's the same answer. So any 3 of these answers is acceptable in my view. Okay? Any 3 of those answers are acceptable. I don't think there's another way. That's pretty much it. Okay? All right. Let's look at another one. A cubed minus b cubed over a squared minus b squared. Now, don't get smart and say, oh, well, a cubed over a squared is just a, and b cubed over b squared is just b, so that's a minus b. It's not, okay? That's not equivalent to a minus b. We got to factor it, okay? We got to factor it. So the top is perfect cubes. A, B, square the A, multiply them together, AB, square the B. So same, opposite, always positive. This is why we went over that factoring stuff. The bottom is the difference of perfect squares. A plus B times A minus B. So the only thing that cancels are the A minus B's. Bless you. That's all we can do. I know that the trinomial in the difference of perfect cubes looks like it's factorable. It's very close to being factorable, but that trinomial there is never factorable. You can never go further than that. So this is fully simplified. And you're probably looking at that and saying, well, I have more terms than what I started with. How did I just simplify that? Well, you did take it down a degree. Okay, you did take it down a degree. All right, questions so far? All right, a few more just to make sure we're all on the same page with factoring. Let's look at y squared minus 7y plus 12 over y squared plus 3y minus 18. I want y'all to kind of do that there on your paper. I'll be doing it up on the board, but I want you to try and do it yourself because this one's pretty simple. Okay, that one was just simple trinomial factoring. Y minus 4, y minus 3 in the numerator. Y plus 6, y minus 3 in the denominator. So the common factor there is the y minus 3. So let's look at E. 2 minus x plus 2x squared minus x cubed over x minus 2. So what kind of factoring are we talking about in the numerator there? Grouping. Okay, yes, it is going to be grouping because we got 4 terms. That's our only choice when there are 4 terms. It's usually always grouping. Now, it's not in standard form. We don't like things that are not in standard. I don't know about you. I don't like things that are in standard form. So I'm going to flip this thing around so that it is in standard form. Okay, so negative x cubed plus 2x squared minus x plus 2. What's the GCF of the first pair? Close. Negative x squared. Remember, when that leading term is negative, we want to take the negative out. So if we take the negative out, we're left with an x and a minus 2. How about in the second pair? All we can do is take out a negative 1. Now, we can look at this a couple of different ways. You can go ahead and continue with your grouping, or technically we can cancel right now. Here's a term, and here's your term. Do they all have something in common? Yeah, they all have that x minus 2. Now, just be careful with this, that you don't lose that minus 1 right there. Okay, don't lose that minus 1, because you kind of got to hold that place. So we canceled out the x minus 2, so all we're left with is the minus x squared minus 1, which is not the difference of perfect squares. You could try it. I mean, we're done simplifying, but if you really wanted to factor it, you'd have to take out the negative, and if you take out the negative, it becomes positive 1, so it's not the difference of perfect squares. Yes, ma'am? Yeah. You can finish out the grouping, okay? You can finish out the grouping. I just wanted to point this out. You can finish the grouping. You can write that as x minus 2 times negative x squared minus 1 and then cancel the x minus 2's. I just wanted to point this out for those of you who like to stop writing. All right, one more with the grouping here. Okay, x minus 3 over x cubed plus x squared minus 9x minus 9. Thankfully, we do not have to change the order here. The numerator does not need any factoring because it's a linear factor. Our first pair, we can take out an x squared. I'm going to do that. We're left with x plus 1. What do we take out of the second pair? Negative 9. Okay, make sure you get that negative out. Here is why I tried to give you several examples of where when you do the factoring by grouping, it needs to factor more, because right now there's nothing that can be simplified. We're stuck right there, but if we finish the factoring like we're supposed to, x squared minus 9 factors into x plus 3 times x minus 3. So now we can cancel something out. Now, I canceled out the numerator, but the stuff in the denominator doesn't jump up to the numerator. We got to put a 1 up there to hold the place, to hold the numerator. Okay? Because when you cancel something, and this is another common misconception, when you cancel something, it doesn't equal 0. When you cancel something with division, it doesn't equal 0, it equals 1. X minus 3 divided by x minus 3 is 1. It's just like if you had negative 3 divided by negative 3. It's 1, it's not 0. If something cancels by division, it equals 1, it doesn't equal 0. So you got to put a 1 up there in the numerator to hold its place. Okay? So that's simplifying. Tomorrow